This is 13.3. It's the radian measure. Like I said, you're going to learn to measure an angle in something other than degrees, and it's called radians. How about that? So here we go. Something that you're already familiar with, central angle of a circle is an angle with a vertex at the center of the circle. So this is your central angle. And do you remember what the measure of the intercepted arc is? From geometry? It equals the measure of the angle. Okay? The intercepted arc is the portion of the circle with endpoints on the sides of the central angle and remaining points within the interior of the angle. So this is the intercepted arc of this central angle. Okay. When a central angle intercepts an arc that has the same length as the radius of the circle, the measure of the angle is defined to be 1 radian. Like degrees, radians measure the amount of rotation from the initial side, this is my initial side, the x-axis, to the terminal side. Since the circumference is 2 pi r, there are 2 pi radians in any circle. Okay, because our r is 1. We're still on the unit circle. So, if that is the case, what we are familiar with, the circumference, a whole circle, what we're familiar with is 360 degrees, right? So that means 360 degrees is the same thing as 2 pi radians. It's like 1 yard is 36 inches. You accept that. It's 2 different types of measurement, but it's measuring the same length. 1 foot is 12 inches. You can measure in feet or inches. 360 degrees is 2 pi radians. And remember what pi is. Pi is around 3.14. So it's around 6.28 approximately radians. Okay, so if I divide by 2, pi radians equals 180 degrees. This is a little formula. If you put degrees over 180, then the number of radians equals pi. Okay? Because that's how you can do it. But I'm going to show you a quicker way than that. Okay. And where are they? Let me go there. Yeah. Okay, so if I want to find the radian measure of 60 degrees, what you can just do real easily is just multiply by pi over 180. Because here, I'll do this. If you cross multiply using your proportion, you would get this. And if I would find what the degree is, you would have, you would divide by pi on both sides, and you would get 180 degrees over pi, because r is 1, okay? If I wanted to go the other way, if I would go this way, degrees pi equals 180 r, and I want to solve for r, you would get so you would just be multiplying the degrees, which is 60 degrees, and I'm going to multiply it by pi over 180. And you would get pi over 3. That is it. And I'm going to explain something in a second and you'll see. So if you're going from degrees to radians, when you're going from degrees to radians, all you have to do is multiply by pi over 180 because of this proportion. If you're going from radians here to degrees, what do you think you do? Any guesses? Very good, Abraham. You multiply by 180 over pi. This cancels. Goodbye to the pi. You get 90, and you will get 250 degrees. So if you're doing this one, you're going to multiply by 180 over pi. Now, to have this make sense to you, draw a little circle in here. We all know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then we're back up to 360 degrees. Now, remember 360 is 2 pi radians. So over here, this would be what? How many radians do you think? You would divide by 2, right? If a whole circle is 2 pi, then 180 we have right here is pi radians. So what do you think 90 is in radians? If this is 0 radians, it would be pi over 2, right? It would be 1/2 pi, which is pi over 2. This is pi over 2 radians. That's the same thing. So this is 0 radians, this is 1/2 pi radians, this is pi radians. What do you think 270 is? From 1 to 2, what's in the middle of it? 1 and 1/2, right? Which is 3/2. So we would call this 3 pi over 2 radians. So 90 degrees is the same thing as pi over 2. So let's make sense of what we just did. 60 degrees would land in the first quadrant, right? It's between 0 and 90. Notice what our radians is. It's 1/3 pi. Isn't that between 0 and 1/2 pi? It would land here. Okay, let's look at this. 5/2 pi is really 2.5 pi, right? Remember 2 pi is one circle? One complete circle, right? And then another half would put me where? Up here. Well, if I go in degrees, 360 plus 90, where do I end up? At 450. So those are equivalent, okay? This is the measurement in radians, 5/2 pi or 2.5. That means 2 pi plus 1/2 or 450. So right here to convert degrees to radians, that's what I just put up here. You multiply by pi over 180. Here you multiply by 180 over pi. So if I'm converting this to degrees, first of all, let me ask you before we even do that, where would that land on the unit circle? Which quadrant? Who knows? Raise your hand. No one knows. Borna? Third one?
Sorry, the second one.
Second one. 5, 6. Isn't that between 1 and 1/2 and 1? So won't it land somewhere in the second quadrant? So shouldn't our answer be between 90 and 180 degrees? Okay, so let's see. If I multiply, I'm converting 2 degrees. I'm going to multiply by 180 over pi. The pi's cancel. 6 goes into 180. 30 times you get 150 degrees. Isn't that in second quadrant? Okay, let's look at this. 225 degrees. What quadrant is this in? The third. So that means when I convert to radians, it should land between 1 pi and 3/2 pi, right? Okay, let's see if it does. We take 225. I'm going to multiply by 180. Whoopsie. Pi over 180. 45 goes into this 4 times. 45 into here 5 times. you'll get 5 pi over 4 radians. Okay? Where will that land? This is between 1 and 1 1/2, so it would land in the third quadrant. Now, whenever it says exact values, that is when you use the circle and you draw your right triangles, everybody. Okay, so when you see that direction, you don't ever use a calculator on these right now, and we are drawing the circle. So first of all, cosine of pi over 4. Where will that land? Which quadrant? 3? 1/4 pi? Where will that land, you guys? First. And if I convert this to degrees, I'm going to convert to degrees. We won't have to always be doing this, but I'll show you why in a second. I will multiply by pi 180 over pi, and you get 45 degrees. So my unit circle, this would be 45 degrees is the reference angle. This is 1. This is radical 2 over 2, radical 2 over 2. 45, 45, 90 is easy, isn't it? Because both of the legs are the same. You just have to watch your positive and negatives. So my cosine is x. Pi over 4 would be radical 2 over 2. The sine of pi over 4 is radical 2 over 2. You get the same thing. This is really the cosine and sine of 45 degrees. Okay, turn the page. Now, length of intercepted arc. You guys have had this in geometry, but you're going to learn another method that you need to know for radians. The length of an intercepted arc for a circle of radius r and a central angle degree, or theta, in radians. It's in radians. The length of S of the intercepted arc is S equals the radius times theta. Theta is in radians, not degrees. This stands for radius, the length of your radius. Now, you did this in geometry. You had a different formula. In geometry, you had degrees over 60 times 2 pi r. So if it was 60 degrees, it was 1/6 of a circle, and you're taking 1/6 of the circumference. Doesn't that make sense? If it's like 20 degrees, you're taking 1/18 of the circumference of the circle. Now we have another formula when it's in radians. Okay, so find the length S of the circle at right. This measurement is in radians. All I do is use your formula. The radius is 4 times 5 pi over 6. You would get 20 pi over 6, reduce 10 pi over 3, and its measurement is in the units of the length of the radius. So if this was in inches, this would be inches. If this was in centimeters, it would be centimeters. And we just found the length of this intercepted arc. Okay? So let's try what we just learned. Convert the following angles to radians. What would I do on this? Anna, what would you do on this? What would I do with the 45? Look at your notes on the other page. We just did a bunch of them. Okay, then let's look at the box. If I want to convert to radian or convert degrees to radians, what do you do? It says pi over 180. You need to write stuff down. Stay with me. This is all new to you. So you have pi over 180. This reduces and you get pi over 4 radians. Okay, Anna, what would you do on this one?
120 times pi over 20.
And that would reduce to 2 pi over 3 radians. And think about our unit circle. Isn't this between 1/2 and 1 pi? Which is between 90 and 180. Okay, a whole circle's 2 pi, so half of it's pi. Easy to remember. Abraham, how would I convert this to degrees? Okay, and notice what that is. It's pi over 2. That is just 90 degrees, right? Tyler, how would I do this one? To convert it to degrees. Tyler, how would you do this?
You times over 180 over 5.
We're having issues, Tyler.
Yeah, sure.
Stay after class, I need to talk to you. Okay. Okay, so you get negative 135 degrees. Okay. Andrea, if I want to find the exact values, what am I going to have to do?
Well, you have to use it in the radical.
Very good. You have to leave it in the radical form. So what do I have to form? What am I going to use here? Armin? The circle, and I have to make a right triangle, right? So I've got the circle here. Layla, what else do I need now? Convert it to degrees, and 2 pi over 3 to convert to degrees. What would I have to do? 180 over pi. And you would get 120 degrees. So where's my terminal side going to land, Pooja? In the second quadrant. And Zen, what's my reference angle? 60. And my short leg, camera D, is the X or the Y? The X. So if this is 1, so what is the measurement of X? 1/2. And what would this one be? And let me just, and some of you might say, of course it is. But 1/2 is shorter than radical 3 over 2 because radical 3 is approximately 1.4. So that's 0.7, this is 0.5. This is shorter than this. Okay, so for you to understand. Are any of these negative, Karen?
The x's.
The x's. So if I had to find the cosine of 2 pi over 3, Josephine, what would you get? Negative 1/2. And Daniel, the sine of 2 pi over 3, what would that be? Root 3 over 2. And you're done. Okay? So on here, Winsy, what would this be in degrees? 90 degrees. We don't really even have to convert that. We know that. So, can I draw a right triangle when it's at 90 degrees? No. Alex, what is the ordered pair here? 0, 1. Because the radius is 1. So what is the cosine? Who do I want to call it? Abraham, what do you have? What's the cosine of 90 degrees? 0. And Sarah, what's the sine? Perfect. Okay, if I want to find the length of this arc, I need to know what the radius is. Okay, to use the formula, can I just say 10 times 80? Pardis, can I just say 10 times 80 on this one to use this formula? It's not from what? Did you? You're actually finding what this length is, if you would draw a circle. Okay, so what you're trying to do, but you need to convert this to radians. That's where I was going, because theta is in radians. So I have to go 80 times pi over 180, which is 4 pi over 9. And then what's my radius? 10 times 4 pi over 9. And we would have 40 pi over 9 inches. Kamyari, did you have a question?
Can we go over B again?
B,
Yeah.
you know that's 90 degrees, right? Okay, 90 degrees, it would take you right up here. Can't form a right triangle when it's on the axis. This point is 0, 1 because the radius is 1. Right?
Yeah.
So cosine is x over r. 0 over 1 is 0. This is 1 over 1, which is 1. Okay. Now, yes, Alex.
What did you know the radius was?
I didn't. I forgot to put it in. I added it. Okay, so this hopefully will make sense to you when we fill this all out. And I want you up here, and Anna, please write this down, is that you have here, and this is your 1, 0. This is 0, 1. This is negative 1, 0. This is 0, negative 1. Remember your cosine of theta is x, because it's x over r, and r is 1. And the sine is y, because it's always the opposite. And opposite your reference angle is always going to be the y. The adjacent is always the x. I just showed that to you over there. That was the purpose of the warm-up. So on here, this is pi over 2. I want to go in a different color. Pi over 2. Maybe it can't. This is pi. This is 3/2 pi. And this is 2 pi. Also, in the first quadrant, we all know that the ordered pairs are positive, positive. This is also your cosine sine. This is negative, positive. This is negative, negative. And this is positive, negative. Now I'm going to show you some patterns here of what's happening. Over here, this is all in radians. We go from 0 here, so right here we know that this is 90 degrees. Let's just put it in. This is 0 degrees. Please fill this in. This isn't for me, it's for you. This is 180 pi. I'm hoping that you're going to see a pattern. This is 270, and this is 360. This is your angle measured in degrees. This is radians, obviously. Now, we'll fill this in a second. You're going to start to see something happen. When I convert radians to degrees, I multiply by 180 over pi. I'm not going to do this to all of them. You're going to see something. This is 30 degrees. If you look at what the reference angle, remember, which is made up of the x-axis and the terminal side, if this is 30 degrees here, my reference angle is 30 degrees, obviously, right? Here you don't really have a reference angle because it's on the x-axis. Okay. On here, if I multiply by pi over 180, you're going to get 45. And my reference angle is 45 because it's all in the first quadrant. This, if I multiply by 180 over pi, I get 60 degrees. This is also 60 degrees. Now, if you look at these, if you look at this one at the 6, your reference angle, if it's if the denominator is 6, it's always going to be divided into 180, right? So no matter what, your reference angle will always be 30. So on this one, I'm not going to worry about this side. This is also 30 degrees. It's going to have the same reference angle as this because you'd be dividing by 180 over pi. And that would be 30, and 30 times 5 is 150. And it's 30 there. Okay? So here, this is also 30. And this one is also 30. My reference angle is always the same if the denominator is 6. 180 divided by 6 is 30. So your reference angle to the x-axis is 30. Notice if it's the denominator's 3, my reference angle is 60. So this would also be 60. This one would also be 60. I'm talking about reference angle right now. And this would be 60. If it's divided by 4, it's always going to be 45. The other ones, when it lands, is if it's divided by 1 or 2, it's on the x or y axis. So now how does that help us with the degree? If this is 60 degrees, notice if I add 30 to this, this is just 120. Because between 120 to 180 is 60. What do you think this one's going to be? What is the measure without multiplying by 180 over pi? Can you tell me if the reference angle is 45? Which quadrant is it going to land in? Second, wouldn't this be 135? And this one, if it's 30, and 30 from 180 is, what do you think? 150. And then here's your 180. Now you're 30 degrees past 180. What would this be? 210. You're in the third quadrant. This is in the third quadrant with a reference angle of 45. What's 45 and 180? 225. And this would be 240. What's that?
Those. It's 210, yeah, those.
Okay. Remember, this is what we're being drawn to. 180 to 210 is 30. 180 to 225 is 45. 180 to 240 is 260. This is the x-axis. Listen, honey. This is the y-axis. We don't draw our triangle to this. When we were doing the other side, this is the 180 when it was in the second quadrant. 150 to 180 is 30. 135 to 180 is 45. 120 to 180 is 60. We were drawing it up to the 180. Okay, now here, when it's in the third quadrant, I'm drawing it up to 0 or 360. So this would be 300. 300 to 360 is 60 degrees. This would be 315. And this would be 330. You're always drawing up to the x-axis. And these are the x-axis. Now, how would that help us in this? If you look here by, let's just do the x-axis, this is 1, 0. We know that. At 90, it's 0, 1. Abraham, do you not have a packet? This is negative 1, 0. And this is 0, negative 1. And this is back to 0 again. At 30 degrees, if your reference angle is 30 degrees, think about this. If your reference angle is 30 degrees, opposite that is at the short or the long side. Short. And is that the x or the y, the opposite side?
Y.
The y. So that means this is 1/2 and this is radical 3 over 2. All of the ones that have reference angles are the same. This would be radical 3 over 2. This would be 1/2 also, the 150. This is also radical 3 over 2. This is 1/2. All of them are the same. Here, down here at 30 degrees at 330, this is radical 3, this is 1/2.
Wouldn't it be negative?
Okay, we're going to get there. Good for you.
So it's better to memorize it, right?
Better to understand it, not memorize. Okay, so on here, very good. All of these, this is all in the second quadrant. This is all in the first. This is all in the third. And this is all in the, oh shoot, I missed it. This is all in the fourth. So if these are in the second, you're exactly right. The x is negative. Okay, but let's worry about that later. Yes.
On the left side, on the bottom, isn't the reference angle decreasing? So what is it?
This one's 30.
But it goes from 60 to 45 to 30. So
If it's at 330, you're drawing it up to the 360. And between 360 and 330, you aren't going up to here. That's to the y. This is y-axis. No, no, no. This is the x-axis. This is the x-axis. Remember, you always draw your triangle to this number and to this number. Okay? Good question. Okay, so now, the 60 degrees is just reversed. This is 1/2. This is radical 3 over 2. This is 1/2 radical 3 over 2. This is 1/2 radical 3 over 2. And this one is 1/2 and radical 3 over 2. We'll go back and put in our positive and negatives. And 45, 45, 90 is a dream, right? Why is it a dream? They're both the same. They're radical 2 over 2. So you have filled this chart out. Like this, and I wanted you to see patterns. Now, in the first quadrant, all of them are positive. In the second quadrant, your x's are negative. In the third quadrant, both of them are negative. And in the fourth quadrant, your y is negative. And you have it. So when I say 5 pi over 6, what's the reference angle? 5 pi over 6. 30, because 180, and which quadrant does it land in? Second quadrant, because 5, 6 is between 190 and it's between 1/2 and 1 pi. So it's 30 degrees, so you know that its opposite side is, the y is the short leg. So I want you to be able to visualize and understand where all this is coming from. And when you see it like this, and you see the degrees and the radians, does this all make sense to you? It's really following all the same rules, right? Okay, so eventually we don't want you even thinking as 3/4 pi as a reference angle of 45. We want you to know it's in the second quadrant, and it would be pi over 2, radical 2 over 2, radical 2 over 2 is your x and your y, okay? And then you'd have to think about the positive and negatives. Does that make sense? So in your homework, where it says exact, from 14 to 19, you do exact. 37, 38, 41, and that's with doing your circle. This is putting this whole thing in. Okay, now I'm gonna pass back your test because I